Okay, today we're going to be looking at the integration method. So let's get an equation set up. This is going to be the general concept that you will follow for these types of problems. So we're going to have dy over dt plus pt times y is equal to, let's just say gt. So the whole idea is we're going to use something called a multiplying factor or an integration factor, which we are going to call mu. That is a terrible mu. Mu t is equal to e, the integral of p t dt. So we're gonna break this apart. I'm gonna show you the process and what you do to do this, and I'm also gonna show you where we get this equation from. So next step is we're going to multiply mu of t to everything on both sides. So we're going to get mu t dy dt plus mu t p t y is equal to mu t g t. So this whole thing, why it's actually called the integration method, is this is all going to turn into d, the derivative of mu t. Let's get this a little bit closer. Mu t times y, and this is what it's going to be when we use the chain rule, or sorry, the product rule. When we multiply this out, it's going to equal that, and that's going to be equal to mu t times gt. So this whole step right here is how we're going to start looking at how we get this. So to make this possible, what we have to do is make this right here equal to this. So mu of t dy dt plus mu t p t y has to be equal to dt, or d over dt mu t y. So the derivative of ut, or mu t y, is equal to this. So we're going to use the product rule, which is f of x, the derivative of f of x g of x is equal to f prime x gx plus f of x g prime x. So with this, you're going to get d mu t over dt times y plus dy dt times mu t is equal to mu t dy dt plus mu t p t y. So we want to first look at this. We have a dy dt times mu t on both sides, so we can get rid of both of those. So that leaves us with I'm gonna switch these. I'm gonna switch this to the other side. So we have d mu t dt times y is equal to y mu t p t. So then we can also get rid of a y. We can divide the whole thing by y, which is going to give us d mu dt dt is equal to mu t pt. So now we're going to do something that we've done before, which is separation by parts, or separation of variables, sorry. So we're going to bring this ut over here and bring over this dt. So we're going to have d mu dt over mu t is equal to pt dt, and then we are going to integrate both sides. So I'm going to move over here. So this is going to equal the natural log of mu t is equal to the integral of p t dt, but we want to solve for mu t, so we're going to take everything to the e to get rid of this natural log. So it's going to be e. So then we're going to get mu t is equal to e, the integral of p t dt. So this is how we get this right here. That's how we prove that the derivative of mu t times y is equal to this when we follow what mu t is equal to. So then the next step in the integration method is we're going to take the integral of both sides to the dt. So you're going to get mu of t times y is equal to the integral of mu t g t to the dt, and then y is going to be equal to the integral of mu t g t dt all over mu of t. So that is the basic steps right here. Oh boy, oh god. That is the basic steps on how we do the integration method, and then this is just the proof of why mu of t is equal to e to the integral of pt dt. So next I'm gonna do a basic example, and we're gonna solve a first order linear differential equation. So we're gonna look at a basic example such as dy dt plus 5y is equal to 3. So from we know it before, this 5 is our p of t. So mu t is equal to e, the integral pt dt. So that is going to be equal to 5 dt, which is going to be equal to e to the 5t. So now we're going to multiply u of t to everything in this equation. So we're going to get e to the 5t dy dt plus e to the 5t times 5y is equal to 3e to the 5t. And then from the proof before, we know that e to the 5t dy dt plus e to the 5t times 5y is equal to d dt times mu t y. And to quickly solve that, d dt times e to the t times y with the product rule. So e to the 5t is going to be 5e to the 5t times y plus dy dt times e to the 5t. And if you see 5y, e to the 5t, that's equal dy dt, e to the 5t, that's our proof right there. So that is all equal to e to the 3 to the 5t. So, and I should write that out. E to the 5t y d dt is equal to 3e to the 5t. So now we're going to integrate both sides with respect to dt, which is going to give us 3/5 e to the 5t plus c is equal to e to the 5t, y. So now we want to get y by itself, so we're going to divide by e to the 5. That looks like, they all look like s's, I'm sorry. We're going to divide by e to the 5t, which is going to then give us y is equal to 3/5, and then this is going to cancel out, plus c e to the negative 5t. This is in the denominator, so I'm going to bring it up and just make it a negative. So this is our basic example of using the integration method to solve a first order linear differential. I'll be doing, I guess, a little bit more challenging ones in another video.